This is about setting targets and contingencies for project costs. We have a base cost estimate and we know that the actual cost could be somewhere in a range around that value. With suitable analysis, we can assess the likelihood of values in that range, and from this we can set a contingency and possibly a management reserve that will give us an acceptable level of confidence that targets will be met, and if they're not, then the consequences can be managed. Two common methods for assessing cost uncertainty are risk event modelling and line item ranging. Risk event models are often built up from a risk register with a probability and impact assigned to each risk. The impacts might be represented by distributions and combined using Monte Carlo simulation. Line item models are usually based on a summary estimate with an allowance for risk against each part of the cost, again represented by distributions and combined using Monte Carlo simulation. These both look plausible, but they're not good choices for the primary approach to analysing project cost risk. They introduce complicated interactions that are hard to model well. There's a real danger of impacts being double counted, especially in delay costs. They don't fit the way we think about uncertainty in project costs, and they often result in unrealistic assessments. Both of these methods are hangovers from days when we had to carry out the analysis by hand. We can do a lot better and make the analysis simpler. This is an illustration of parts of a risk factor model for a small IT project. The overhead costs are subject to uncertainty about the running rate of the cost in dollars per month and about the duration. The duration itself is subject to uncertainty about the scale of the software and about the productivity of the team developing it. Uncertainty about the scale of the job and the team productivity also affect the total spend on professional services, along with the uncertainty about the market rate for professional services. And then it may be that the cost of installed licenses will be subject to uncertainty about the number of end users and the market rate for licenses, as well as a design decision, possibly a choice of operating system or some other feature of the system. That design decision, as it is shown here, would be an event in reality, and so it would be modelled as an event in the model. It's either one thing or the other, not somewhere in a range. The uncertainty about rates, scale and duration is all variation within a range, not events, and it's important to keep the two distinct. Risk factor models are straightforward and easy to understand. Building them generates useful insights into the sources of uncertainty affecting a cost. It helps us work out what causes the overall uncertainty, the spread between the high and the low ends of the range, and also what drives the contingency. This is all explained in more detail in a slightly longer accompanying presentation.